Welcome to the session number 8, Project Quality Management. You have to manage the quality of your project, and there are specific methods that are required to be followed. So, in this session, what we need you to know is to understand the importance of quality management, to be able to describe the main processes of project quality management and understand how they relate to projects, to be able to describe the quality control techniques and understand the contribution of the major quality experts to quality management, and discuss quality standards and models. So, to begin, what is quality? We can talk about quality of design, quality of conformance, and fitness for purpose. In quality of design, you've got to decide the level of quality required. That's the characteristics of the product or service, such as grade of materials, performance specification, etc. Conformance will imply the degree to which the design specifications are met or conformance to requirements. And fitness for purpose would mean that the product can be used for the purpose it was intended for. And this is usually considered to be more rigorous than fitness for use. So fitness for purpose is a different concept to fitness for use. There are a number of views on quality. You can view quality as a product-based or quantity. There can be a user-based view, a specification, a value-based approach, or a transcendent property or a continuous property. How would you view a quality? What would be your approach? The view you take will inform how seriously you approach quality within your project. What is the cost of quality? If you want quality, it will cost you something. So the cost of quality includes all the costs associated with the quality-related processes. So the cost of quality factors include prevention costs, appraisal costs, and failure costs. What do each of these mean? Now, the cost to fix something escalates as you move towards a field use or operation use. So the diagram you have here shows you how much the cost escalates depending upon where you find the cost. So, assuming you find the cost during the requirement, you find the error during the requirement stage, then that's a unit 1. Then if the error is found at the design stage, then the cost to fix it goes up by 3 to 6 times. If you find the error at the coding stage, then the cost to fix it goes up about 10 times. And if you find the error at the development or the testing stage, then the cost to fix it goes up by about 15 to 40 times, and so on and so forth. So you can see that it can be very expensive if you don't find the cost early on. To manage quality, you need to plan. So you have to do quality planning, quality assurance, and quality control. The planning will involve identifying the relevant requirements, quality procedures and standards, and determine how a project will meet them. Quality assurance will involve you carrying out the planned quality activities to ensure that the project delivers a quality product or service. Quality control, on the other hand, will involve monitoring the project results to ensure that they meet the relevant quality standards. Outputs could include quality control status reports, rework, and process improvements. There are a number of quality control methods. We've talked about management reviews in the previous sessions and testing, but then there are other methods which I need you to read up on. There's a Pareto analysis, the control charts, the walkthroughs, and then the inspections. This is a diagram of an example of a Pareto diagram, where it shows the number of defects over a given time, and then the cumulative percentage error, and then the things that account for it. So, for example, insufficient qualified data, is a missing source code, missing benchmark data, etc. This is an example of a control chart. So you have the mean error, then you have a lower control limit and upper control limit, and these are defined by the standard deviations or sigma. So there's a mean value or error value, then it can be either one standard deviation or lower or above, 2 standard deviations, or 3 standard deviations. So in this particular case, the upper control limit is 3 standard deviations, and the lower control limit is what? Also 3 standard deviations. So in this particular case, you can see that there's a violation of the control limit on one occasion. Otherwise, it's normally between 1 and 2 standard deviations. What is a walkthrough? It is a type of peer group review. It's normally informal and may last, say, 1 to 1.5 hours. Its purpose will enforce standards, detect errors, improve visibility of the material and overall system quality. The product author typically will describe the structure and logic of the material being reviewed. A coordinator will plan and organize a walkthrough. An action list of problems and questions is generated, and an outcome decision about whether the material can be accepted as it is or whether it needs revision, and even a further walkthrough, a decision is made on that. What are inspections? These are carried out on written documentation. The idea was originally developed by Michael Fagan for use on source code. It has been extended, however, for use on other documents, and extended also by Robert Mays to support continuous process improvement. Inspections need to be economic, and they can be used for training about standards. They, however, do not replace testing, but can be argued to find defects earlier than testing. You have checkers who are given rules. They use rules and checklists to find issues. So you develop a checklist, and some rules. And these are then used to find issues that may arise. And you check against the source and similar documents. The author has a final say if issues are defects or not. This diagram gives you an overview of how the inspection process takes place. So you can have a look at it. There's an entry point, a planning, a kickoff, checking, specification meeting, edits or audits, process meetings, and so on. There are a number of important people or key people who contributed to the quality movement, and it's important to find out about these people. This includes Walt Schirra, Edward Deming, Joseph Juran, Philip Crosby, and Kaoru Shikawa. The question you should ask yourselves when you read up on these people are, what has been the contribution of each of these individuals? Continuous improvement tries to continuously striving to produce better products and improve the processes. The key requirement is that an organization has a stable process so that the impact of any change can be understood. Often, this is misinterpreted as an organization has to have processes. No. There's a 6 Sigma approach, which is a holistic approach to quality. An organization sets out a high 6 Sigma goals and uses continuous process improvement to achieve them. The 6 Sigma goal is no more than having 3.4 defects per million opportunities. It's a process that has been adopted by huge companies like Motorola or General Electric. The 6 Sigma improvement process, 1, identifies a project, defines the project, measures the current process performance, analyze and probe the problem, develop the improved processes, implement the changes, control, measure and hold the gains, and communicate the achievements in other areas. There's an important industry quality standard, the ISO 9000-2000, which provides standards for quality management with respect to improved customer satisfaction and continuous improvement. It focuses on 8 principles: customer focus, leadership, involvement of people, process approach, system approach to management, continual improvement, factual approach to decision making, mutually beneficial supplier relationship. There's a website where you can find further information on the ISO.org, www.iso.org. Another one is TIC-IT, which provides a framework for organizations to get certification under the ISO 9001-2000 framework. It develops quality management system certification procedures. It advises on training, selecting and registering auditors with IT experience and competence, and also introduces rules for the accreditation of certification and bodies in the software sector. It also publishes guidance material for interpreting the requirements for the ISO 9001. Maturity models provide frameworks for organizations to assess their overall capability. The aim is to help organizations understand what they need to do to achieve process improvement or enhance organizational capability. The capability maturity model integration was developed at Carnegie Mellon University. So there's a website where you can go and read more about it. There are 2 instantiations of it there, the staged one and the continuous one, which you can find out further details. Well, we can stage this in a diagram, the initial stage, the managed stage, the defined stage, and the quantitatively managed stage, and the optimizing stage. The maturity level 1 is the initial processes. They are ad hoc and chaotic. The level 2 are managed processes, are planned, performed, measured, and then controlled. The level 3 become defined processes, defined. The processes are qualitatively predictable. At level 4, they are quantitatively managed. So the processes are better understood in statistical terms and special causes are addressed. Processes are quantitatively also predictable. The level 5 is the optimizing level. The focus here is on improving processes performance by removing common causes. So, the aim of the maturity models are to improve and standardize project management processes. The Project Management Institute produced an organizational project management maturity model, the OPM3, which builds on the project management processes as described in the first session. That's initiating processes, planning processes, executing processes, and so on. And extends into program and portfolio management in the second session. This brings us to the end of this session. Here we have discussed current ideas on project quality management, key people who have shaped quality management, saying that quality must be designed into a project. It's not just about errors and their elimination, it is also about prevention. It's a dynamic process, and it's concerned with the usefulness and acceptability of a product to its users and project clients. Thank you.